Okay, let's take a look on this day 2 practice on the basic application of linear motion. So for the first problem here, we know that an observer stands on the side of the front of a stationary train, and when the train starts moving with constant acceleration, it takes 5 seconds for the first car to pass the observer. So how long will it take for the 10th car to pass? Okay, so this problem here is a classic application of the kinematic equation. So from before, we have learned some of the very important kinematic equations, right? So for example, we know that the delta x, the displacement, is equal to the v0 multiplied by t, the initial velocity multiplied by time, and plus 1/2 times the a times the t squared. Okay, so in this case here, we do know that the initial velocity is equal to 0 because the train was stationary, so we have this part to be 0. The first part here is equal to 0, and then we also have the t to be 5, right? It takes 5 seconds, so we have a 1/2 times the a times the 5 squared. So we can plug in this, so we will have the 25 over 2 multiplied by a. Okay, so we know that the displacement is equal to the 25 over 2 times the acceleration. But in this case, we don't know what the acceleration is. So in physics, like in this case here, you can actually assume that the acceleration is a specific number because we know it's true for whatever acceleration that could be. So in this case, you can just assume that the a is equal, let's say a equals 2. So we will have the delta x is equal to 25 meters. Okay, so now we know that one car has a length of 25 meters. So then how do we know that how long it will take for the 10th car to pass? So we can actually do like another way. So in this case, we can also calculate the time it takes to pass 9 cars. Because once we know the time to pass 9 cars, we can also compare that with the time to pass 10 cars. And we take the difference to calculate how much time it takes for the 10th car to pass. So to pass the 9 cars, we will have, again, the v0t will be just a 0. And then we plus 1/2 times the acceleration. We say that it's going to be 2. So multiplied by a 2 here. And then we multiply by, let's call this to be the t9. So we can solve this equation. The t9 squared is equal to a 9 multiplied by 25, or we will have the t9 is equal to a 15 seconds. So we know that it takes in total 15 seconds to pass the 9 cars. And then what about 10 cars? So again, we just take 10 multiplied by this delta x, right? It's also going to be 0 plus 1/2 and multiplied by 2 multiplied by the time to pass 10 cars. And if we do the calculation, the time to pass the 10 cars is equal to a 10 multiplied by 25. So 10 times a 25 over here. So you can see that the time is going to be 5 multiplied by the square root of 10. And now you can just also do an approximation because you can find that the problems here are in decimal. And you can just do this here using a calculator. So remember, you can bring a calculator to the test. So feel free to use a calculator if you want to. All right, so this will be a 5 times a square root of 10, which equals roughly 15.81. All right, so now if I can find the difference, it will be 15.81 minus 15 seconds is equal to a 0.81 seconds. So we know that to pass the 10th car, it takes in total 0.81 seconds, and we have our final answer. Okay, so this will be the first problem here. And then for the second one, this one was a more recent problem here, and it's also problem 2. So it says that a car travels directly north on a straight highway at a constant speed of 80 kilometers per hour for a distance of 25. And then the car continues directly north at a constant speed of 50 kilometers per hour for a distance of 75 more kilometers. The average speed of the car for the entire journey is. So this problem is asking about the average velocity. And how do we calculate the average velocity? We must take the total displacement and divide it by the total time. Right? So in this case here, we can see that the car actually has two separate like constant velocities throughout the trip. The first part is going to be the 80 kilometers per hour for 25 kilometers. And the second part will be 50 kilometers per hour for a trip of 75 more kilometers. So we have actually two like displacement here. And because we can see the car doesn't change the direction, it's just going to be one direction. And now we are going to have, so let's say that the delta x total is just equal to 25 plus a 75 equals 100 kilometers, right? The total displacement is very simple. And then we also have the total time. So we can calculate the time by using the displacement over the velocity. So we can just take a 25 divided by 80. You can also use the dimensional analysis to figure out the correct order. So we have 75 divided by a 50. And then we just need to do this calculation. And again, just grab a calculator. Don't torture yourself. Just do this with a calculator. And we have a 75 divided by a 50. All right, so the final result is going to be approximately 1.8125. Not approximately, but exactly 1.8125. And the unit will be hours. Okay, and once you have this two quantities, you can then calculate the average velocity. It's now equal to 100 kilometers divided by a 1.8125, which is equal to, I think this time here we're going to use the approximately equal to here, but let's double check. It will be about 55. So roughly 55.17. Okay, so the closest answer is going to be the answer choice A, and that's also our final answer. Okay, so this will be it on the applications of the kinematic equations. So you can see that it's just all about the displacement, velocity, and acceleration. If you can know all of this, you will be able to solve the problems. All right, so that will be all.